Testing, 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 testing. All right, guys. Hey, that's how some of the videos begin. This is calculus part 2 of P3. So today what we're going to be looking at are the graphs of a function, like what is a function. We'll learn the easiest method too, and then transformations of a function. And we'll make sure we know what the parent functions are first. So here we go. First off, if you remember any equation or any graph of a function, you're just listing out the point x and it's f of x. So when you plug in, where is it located at? So the one thing about any function, a function needs to make sure that no x value has multiple f of x values. So there's no point where I have a point here x where it would have one f of x value and like another one above it. So you can't have two f of x values on the same spot. Easiest way to do that is called a vertical line test. So if you take a vertical line and go across the graph, if there's no point on it where the vertical line is touching 2 points at the same time, it passes the vertical line test. So you can see here, like, what would fail the vertical line test? This one here would fail the vertical line test because we can make a vertical line here and it touches 2 points on the function or on the potential function on the graph. This one would be fine here, even though it's whirvy and curvy and swervy. We would never have a vertical line that touches more than one spot. And this one actually would work too. Even though we'd have a hole in the graph, it's still a function because it never crosses or never touches more than one spot. So that's the first part of your CYU. Hopefully you guys can handle that, and that should be easy. Okay, next we got some parent functions here. Let's see. You know what I'm going to do is zoom out a little bit, try to get them all on here. Okay, so let me annotate this and do that. I gotta bring this back up here. Annotate. Let's draw. Okay, so let's make sure you guys can identify all these, hopefully real quickly, by their names, and then you guys can we'll worry about the transformations here. All right, so that identity function. This is the y equals x. So what does that look like? Hopefully you remember. If you don't, look it up, Google it. Yeah, that is just a straight diagonal line here. In fact, you know what I'm going to do? I'm going to make a bunch of, we're going to put a bunch of graphs on all these. So I'm going to make, not the best graph drawer right here, but just making points here. And we're going to do your best to fill these out. Square root, absolute value. Still getting used to this digital pen here. It's better. All right, and then we got sines and cosines. Oof. Well, that's good enough. All you really need to know about sines and cosines at the beginning. Okay. And they are technically just transformations of each other. Okay, let's do something. Squaring function. So the calculus book calls them squaring functions. Most of you guys probably call these quadratic functions. So y squared starts down in the middle there, curved up, mirrored, or reflected. Perfect parabola. Cubing functions. All right, so there we go, y equals x cubed. And typically this one goes up, it's curved this way, and then reflected through the origin the other way. All right, square root function, y equals the square root of x. Now, square root function, we're only looking at the positive. It's not plus or minus, so it's just the positive part. So it starts down here and is a sideways parabola. Absolute value. Kind of looks like a parabola, except for it is a straight diagonal line this way, straight diagonal that way. It makes a V shape, Mighty Ducks, flying V. All right, rational function, y equals 1 over x. So this one actually starts off very high. There's a vertical asymptote at 0, and it curves down, starts very low. And if you think about it, like if we have a number like 10, that's 1/10. 100 is 1/100th. You know, 1 is nice. A fraction's actually really high because 1 divided by 0.5 is 2, and it goes up. And then on the other end, it's the same thing, but in the negative quadrant. Ugh, not that great. Yeah, that doesn't make it better if I trace over it. but it's reflected through the origin. All right, sine and cosine. We know sine and cosine are the nice chill waves. Which one's which? Sine starts at 0, goes up, down, up, and it keeps going on forever, but we just need to know through 2 pi in this class. Cosine starts up high, goes down, ends, and ends low. Okay, and technically these are just transformations of each other, but those are the basic functions I think you guys should have memorized, at least in this class. Anything else, I'll give you more to it. But you should know, like an equation, what that should typically look like in your head. All right, so let's clear this all up. Remember too, guys, if I'm going too fast, just pause the video and go through. All right, so transformations, just talking about those. How do those affect the graph? So if we have the original graph, f of x, if we add or subtract a number inside, that's going to move left or right. So kind of opposite intuition here. If I subtract, it moves it to the right. Wait, wrong way. Right. Do backwards in zoom. And if we add, it's going to move to the left. So subtracting, adding. All right. If we subtract outside of the function, so think we have a square root. If I put a minus at the end, it would go down. If I put a plus at the end, it would go up. All right, next, reflections. If I take a negative, so if I have like a negative square root would flip it over the x-axis. So reflection over the x, negative. Inside flips it over the y. It goes left and right. And then origin is an x and a y. So it's kind of weird to think it does go from corner to corner or 180-degree rotation. See if I can do that with my hand here. Is that the same thing? If I go x and y, yeah, that's the same thing as going 180-degree rotation. Ugh. Looking at my video the whole time. Okay, so here's a couple questions. They might look a little familiar to you, but we're gonna match these up here. So if I have the original graph here, f of x, it's right here. I'm going to just kind of highlight. You know what? I think I have a highlighter, don't I? No, I don't. All right, here's the original one. Let's talk about what we're going to do and figure out which ones they match up with. So this one here, I got an x plus 5. So plus 5 is on the inside. So that means it's a horizontal shift. Plus 5 goes to the left. So which one of these graphs is the same thing, just over to the left 5? It starts at 3, go to the left 5, it's going to start at -2. So that one would be D. Okay, next here, we got to a negative on the outside and a negative on the inside. So we're going to flip it down. So it's going to be, instead of a V, it's going to be upside down, or whatever you want to call it, peak. And then we're going to flip it over this way. So flip it over the X and over the Y. And then move it down 2 because we got -2. So the only thing that I see that's flip down and over and then move down would be choice C here. All right, and then lastly, f of x plus 6 plus 2. So we're not flipping or anything here, but we're going to do plus 6. So that means we're going to shift to the left 6, and then plus 2 means we're going to, on the outside, we're going to move it up 2. Looks like E is matching that choice. Okay, so I think that ends this video. We'll go with part 3, the last part, in the next video. You guys have a great day, and I'll see you around.